For this second review, getting ready for our test, I just gave you some extra practice on just the right triangle trig portion of the test. I thought we might need a little extra practice on that. So this is labeled as review number 2, section 14.3 at the top of the little review sheet, and the answers were provided for you on the back. But I thought maybe you're not sure how to get those answers, and so I wanted to provide this video explanation for these problems. So let's just go ahead and we'll get started with these first four. We're going to make a triangle RST to give us something to look at. All right, and we're told that S is the right angle, so I'll just call this R and this T. We're also given the length of one of the legs. This length RS is measured at 24. Okay, what else are we told? We're given a trig ratio for angle R, which is looking out this way. We're given cosine. And cosine, remember, is adjacent over hypotenuse. All right, and so we're told that the cosine of this angle is adjacent 12 over the hypotenuse 13. And some people would say, well, that doesn't seem right because the hypotenuse is supposed to be the longest of the three sides, and that would be correct. So apparently what we have here is a reduced fraction. So if you're not sure, let's just write down this fraction 12/13ths, and then let's just compare what we know. We know the length of the adjacent side, it's been given as 24. So you can kind of reason through, there must have been multiplication by 2 on the top to get 24. So to make this an equivalent fraction, I need to multiply by 2 in the denominator as well. So apparently 12/13ths is just a simplified version of the fraction 24 over 26. So since my adjacent side was given as 24, that means the hypotenuse must be 26. Okay, so it's going to be our job. Before we can find some of these trig ratios, we're going to have to find this third side. You can either think of it as the side ST, or since it's opposite angle R, you might think of it as lowercase r. So let's use the Pythagorean theorem to help us find this missing side. We know the hypotenuse, so it's hypotenuse squared equals one of the legs squared plus the other leg squared. And using your calculator, you can just do 26 squared. We're going to be subtracting 24 squared from both sides to try to solve for R. So my first move, I'll just do this in my calculator. 26 squared minus 24 squared, that is 100. That equals R squared, but I'm looking for R, so that means I've got to do the square root of both sides. And we found the measurement of that third, or that other leg, is 10. And now it should make it pretty easy to find the trig ratios that we're asked to find. For sine R, that's looking out from this angle R, sine is opposite over hypotenuse. So for sine R, the opposite side is 10. The hypotenuse is 26. And anytime I can reduce a fraction, I need to. And if you divide 2 into both of these numbers, you get 5/13. So that's how we got that answer. Okay, now let's shift over to angle T and think about sine T. Okay, so once again, sine is opposite. For angle T, the opposite side is 24. And the hypotenuse is still 26. So now we're reducing this fraction, dividing by 2 into both numerator and denominator. We get the fraction 12/13ths. All right, well, what about cosine t? Still looking from angle T's perspective, cosine, again, is adjacent over hypotenuse. So for angle T, the adjacent side is 10. Hypotenuse is still 26. So we get that same answer that we got for number 1, 5/13. And then finally, cotangent R. Okay, well, cotangent is just the inverse of tangent. And tangent, if you recall, is opposite over adjacent. So if we were doing tangent, we would have 10 over 24. But cotangent is the inverse of that. So it's adjacent over opposite, which means we're going to have 24 over 10, and reducing, dividing by 2, we get 12/5. So hopefully that gives you an explanation behind the answers for those first 4 problems. All right, now let's see if we can get the answers to 5, 6, and 7. So I'm going to make triangle ABC. All right, and we're going to, according to this, we're going to make C the right angle. So we can call these other two, A on the top, B bottom right. We're told that angle A is 29 degrees. And side B, remember the sides are opposite the corresponding letter angle. So if this is angle B, then this is side B. So side B would be called measured at 8. So we're supposed to find side A, which is here, side C, which is here, and angle B. All right, so let's see if we can come up with these answers. Let's start with side A. How would we go about finding this side? It's the opposite of this angle that we know of as 29 degrees, and we're given the adjacent side for angle A. Okay, so let's think about the trig ratio that involves opposite and adjacent. And if you recall, that's the tangent ratio. So the way I'm going to find side A is by going with tangent of the angle A, which is measured at 29 degrees. And that's going to equal the opposite side divided by the adjacent side, which is given. Okay, and I think I'll give myself a little workspace and then we'll come back and fill in the answers. Okay, so solving for A, I'm going to multiply by 8 on both sides of this equation. So my second line here is literally what I'm going to do in my calculator. I'm going to do 8 tangent and then put in 29 in the parentheses, and I get 4.4344 and so forth, but the directions say to round to the nearest tenth, and so that's how we got A is approximately 4.4. All right, so with 2 of the sides found, then we can rely on the Pythagorean theorem, in this case, to find the hypotenuse. So C squared is going to be 8 squared plus 4.4 squared. All right, so let's grab our calculator, and 8 squared plus 4.4 squared, that equals 83.36. That's C squared, but doing the square root of that number will give us C, and that is 9.1301. So rounded to the nearest tenth, we got C is 9.1 approximately. Okay, so we found the 2 missing sides, and then finding this angle B should be pretty easy because we know that the sum of the angles of a triangle add up to 180 degrees. So let's start with 180, subtract the right angle, subtract the given angle, angle A, And once we do these in my calculator, we'll have our measurement for angle B. And that comes out to be 61 degrees. All right, so I would like for you to, when you do your test, give me a really good way of identifying the answers to the missing parts, the ones that you're asked to find. All right, so hopefully that helps you understand how to get the answers for number 5. Now let's work on number 6. Number 6, I'm going to just sketch the right triangle. C is still the right angle. I'm just going to set it up very much like the other one. This time we're given 2 sides. So side A is opposite angle A. So this side will be called 7. And side C is opposite angle C. And we're given the hypotenuse, which is 9. So we've got to find this other leg that would be side B. And once again, we'll use the Pythagorean theorem. So the hypotenuse squared is equal to 1 leg squared plus the other leg squared. Okay, calculator. We're going to do solve for b squared. We'll subtract 7 squared. So 9 squared minus 7 squared is 32. So b squared is 32, but what's b? Well, b is the square root of 32. And that ends up being 5.65685, but rounded we get 5.7. And we'll make this approximate since we rounded. Okay, so we found the missing side. It's 5.7. Now let's find one of these missing angles, and then it should make it easy to find the other one. So I got a lot of choices, although I've asked you to stay away from the decimal side reading when you're looking for an angle. So in this case, if I wanted to find angle A first using a trig ratio, I'm going to use sine. Remember, sine is opposite over hypotenuse. I don't want to do cosine because that would involve using this rounded side measurement, and it's not terrible, but it's going to throw my it's going to make my answer a little less precise. So for your test, I want you to stay away from decimals if you have other options, and we do in this case. So to find angle A, let's put that down here. Angle A, I'm going to use the sine function. Sine A is equal to opposite over hypotenuse. To solve for A, I'm basically going to multiply by the inverse sine. So this is what you're going to do in your calculator. This is where you're going to do second sine. So let's grab our calculator and do second sine. And 7/9 in the parentheses, and we get 51.05755, but we're rounding to the nearest tenth. So angle A rounded will be 51.1 degrees. Okay, and run out of space here. That makes it easy to find then angle B, because once again we go back and we start at 180 degrees and we subtract, let's squeeze it in here, 180 minus 90 minus 51.1, and that gives us angle B, and that should come up to be 38.9. 180 minus 90 minus 51.1, 38.9 degrees. All right, so we got our angle B found, we found our angle A, and we found side B. Okay, I'll just move this over here, give myself a little bit of space. Okay, one more. on this set. Let's do a little triangle. Okay, C, A, B. This time we're given the measurement of angle A, 37 degrees, and we're given side C, which would be on this side, the hypotenuse. It's measured at 12. So I'm trying to find side B, which is opposite angle B, and side A, opposite angle A. So let's see what we can do here. If we want to find, for example, side A, I can use the sine function, because looking from angle A, which I'm given, it's opposite over hypotenuse. So sine 37 degrees, or 37, is equal to the opposite side over the hypotenuse. All right, so to solve for A, pretty simply, I just multiply by 12 on both sides. And I get to use my calculator here. So I'm going to do 12 sine 37. And I get 7.2217, but rounded to the nearest tenth, that's 7.2. All right. So now we can use the Pythagorean theorem to find the other side. So hypotenuse squared equals one of my legs squared plus the other leg squared. So calculator, let's subtract to solve for b squared. So 12 squared minus 7.2 squared, that's 92.16. That's b squared, so b is going to be the square root of that number. And we get 9.6 is our side B. Okay, well, we're almost done. It's pretty easy. When we're given one of the acute angles of a right triangle, to find the other one, we just go back like we were doing before, and we take 180 degrees minus the 90 degree minus the, in this case, the given 37. And in our calculator, we subtract, and we get angle B is 53 degrees. Okay, so that's the way we got those answers for 5, 6, and 7. And we have one more problem on this little half sheet. We have a flagpole problem. The flagpole is 35 feet tall. So here's my flagpole, 35. It casts a shadow. So I'm going to say this is my shadow. Sun shining this way. The shadow is 22 feet long. Okay. The angle of elevation, so some people ask, well, is that going to be this angle or is that going to be this one? Well, angle of elevation, you can think of it this way. If you're standing on the ground looking up, okay, so if this is my flagpole and obviously the shadow is going to be on the ground, I can't have this as an angle of elevation because, well, there's two problems with that. Up here, I'm looking down, so that would be considered an angle of depression. Here, I'm on the ground looking up at the sun, so this is an angle of elevation. And that's what we're supposed to find. What is that angle of elevation of the sun to the nearest degree? Well, let's see. What do we have? We have the opposite side of this angle, and we have the adjacent side of this angle that I've called x. And the ratio opposite over adjacent is tangent. So I'm going to set up an equation that says tangent x is equal to opposite over adjacent. All right. So to solve for x, I'm going to do the inverse. Right now, think of these as being multiplied together. So to solve for x, I'm going to do the inverse tangent function. So I grab my calculator and I do secant tan, and in the parentheses I'm going to do 35 divided by 22, and I get 57.8477, but the directions say to the nearest degree. So to the nearest degree, this angle would be 58 degrees. Okay. Well, I hope that helped out, and just to provide you with a little more practice, but if you still are not sure after watching this video and you've done your own practicing, you're still not sure what to do, you can always feel free to email me, and I will be glad to help you correspond through email, or I can do another video. You just let me know if there's any way I can help you get ready for this test.